Hi. If you're used to using Windows and are moving across to using Linux or Unix, there's a few little things that no one's actually going to tell you, and they're going to cause tremendous confusion. So I'm just going to run through a few things tonight to help you on your way. I'm Frank, and this is Unix Linux for Windows admins. Okay, first off, let's have a quick look at where these things came from. So there's been a lot written about the history of Unix, some of which is actually true. But what you need to know is it was actually written by a couple of guys. In fact, these guys here, Thompson and Ritchie, in Bell Labs for DEC computers. There's a little bit of a project without too many other people involved. There were a number of people involved in writing Unix, but they really just had a vision and went straight for it. I've got a line here that says it came from Multics. Multics was a much bigger, more complicated system that was for multitasking, and they had a little joke and they said, well, this is for single tasking, so we'll call it Unix instead of Multics. So it was a bit influenced by that, but really it was written from scratch. Unix was around for a long time. As you're probably aware, there is a version called Linux, which was a rewrite to be in the public domain. Unix, of course, some versions of Unix are also in the public domain, so it's up to you whether you use the knockoff or the real thing. But a nice, clean, straightforward family history. Unix, there have been different versions of it. It's improved, but fundamentally the decisions that Thompson and Ritchie made, these guys, early on have more or less stood. So let's go to the Windows origin story. This is a lot more complicated. For starters, there was a program called CP/M. You've got to start somewhere. CP/M might have been influenced by TOPS, but basically a guy called Gary Kildall sat down and wrote it. There he is there. And he sat down and wrote a control program for microcomputers targeting the 8080 processor. And it was interesting. He was the first guy, well, he wasn't the first guy, but his operating system, CP/M, used a thing called a BIOS, which is basic input-output subroutines, which meant that every target system that he wanted to move it onto, all he had to do was rewrite the basic input-output subroutines, and you could port the entire operating system from that. So BIOS functions would be things like read a character from the keyboard, write this block to a disk, write a character to the screen, write a character to the printer. In fact, it had paper tape punch and reader stuff in it. But all of that was in the BIOS, and that was the bit that was specific to the hardware. So by writing a BIOS for a particular computer or platform or board or whatever, you could move CP/M across, and it really took off because this was the first portable operating system that would run on multiple machines, and because it could do that, you could write software and it would run on multiple platforms. But the 8080 was not a terribly great processor. In fact, most people ran it on a Z80 processor, but that's another story. And in the end, people started moving over to 16-bit computers, and much to everyone's amazement, IBM and a few others moved across to the Intel 8086 or 8088 processor, which wasn't that brilliant. So Gary Kildall's company, which was Intergalactic Digital Research, or later known as Digital Research, wrote a version of CP/M for the 8086. CP/M86. It was not a great success because most people were just carrying on running the 8-bit stuff. But then along came IBM, and IBM wanted to produce a PC that no one thought was going to do terribly well, And they went to Digital Research and said, hey, how about CPM86 for our PC? And he blew the deal, really, or his wife Dorothy blew the deal, or anyway, they just basically wanted to pay him a low. He was into licensing operating systems, and they wanted their own terms, and the whole thing didn't work out. So IBM was in a bit of a panic. What were they going to do for the operating system for their forthcoming PC? And they found a Mr. Bill Gates, who did not write MS-DOS. He rushed down the road because Microsoft was actually a serious software company. Everyone thinks it was made by MS-DOS, but that's not actually true. Bill Gates wrote a very, very good basic interpreter that was used on an awful lot of computers. And if you wanted Microsoft, if you had a computer, you probably wanted it to run Microsoft Basic. So they went to Bill Gates, who was producing the basic for this thing, and said, hey, we need an operating system. So he rushes down the road to Seattle Computers, Bubba's shop somewhere in Seattle, I guess, and decides to, because he heard they had a CPM86 kind of knockoff called 86DOS, DOS standing for Disk Operating System, which was not written by Bill Gates. It was written by this guy here, actually, Tim Patterson. So Tim Patterson produced a CPM copy, which went into Microsoft. Microsoft, fair enough, they wrote quite a bit of it. For example, they had to write the BIOS to suit IBM's hardware, and you ended up with something that was a bit like CPM, but wasn't like CPM. It was a bit like CPM. Anyway, and of course in those days, intellectual property around software really wasn't an established thing, so they kind of got away with it. Digital Research tried to sue them. There was a big argument. You can read all about that. Doesn't really matter. So you had PC-DOS for the IBM PC, which Microsoft, Bill Gates, found a good way of making some money. He released it for anybody else who wanted it and called it MS-DOS instead. On top of MS-DOS, well, the Mac came out and people wanted graphic user interfaces. Digital Research had a GEM system. Microsoft produced a windowing system called MS Windows, which is down here. Now this has got a lot of baggage by this time, because it's got all the CPM stuff, all the CPM86 and DOS86 stuff, PC-DOS, and MS Windows is running on top of this whole pile of operating system. That kind of went along until Microsoft realized they needed something a little bit more powerful. Microsoft had this wonderful system here called OS2 that was the next big operating system. They were going to sell it to IBM for the next generation of PCs called the PS2, and it was going to be great, except it wasn't very popular. That kind of crashed and burned. IBM took it over. So that was going to be Microsoft's next generation operating system. So what were they going to do? They hired somebody who really knew about operating systems. That was Dave Cutler from, that's in there, from DEC. He wrote VMS, which was an alternative operating system, nothing like Unix, but they decided he's the guy to write the next version of the operating system. So that took the VMS influence down into Windows NT, and some of it came from OS2. These were then merged into Windows 2000, which was where they joined Microsoft Windows and Microsoft Windows NT together and produced Windows 2000, which quickly became Windows XP, and they have had a more or less merged operating system ever since then. So Windows today has stuff from ideas from VMS, OS2, CPM, stuff added by Seattle Computers. It's a bit of a muddle, but by understanding where it comes from, you might be able to realize why things are the way they are. So let's start off with some terminology. Unix uses the following terms for various things, and I'm just going to explain the equivalents. So the root user in Unix is actually the super user, known in Microsoft terms as the administrator. A kernel panic is when the operating system, or the central part of the operating system, can't continue. It's found something that's so badly wrong that it has to give up. And you get a kernel panic on Unix, and the machine will probably reboot, and that's generally bad news. On Windows, you have the blue screen of death that, of course, everyone's much more familiar with. I would say they're probably a little more common than kernel panics. Normally when a Unix program fails, it's just the program that fails and the operating system itself keeps going. Daemon. A daemon is a program that runs in the background and handles various things without you knowing about it, and they just happen. Windows, this is the service, with the service manager and all of that kind of business. So daemons are services and services are daemons. The shell, strictly speaking, in Unix, a shell is the outermost part of the operating system that the user sees. But usually it's referring to a command line rather than a graphical shell, but it could be referring to a graphical shell. It's quite common for people to refer to it as the command line shell. And again, in Windows, you've got the command prompt. You've actually got cmd.exe and you've got PowerShell.exe. So there are two shells there, and there are quite a number of different shells on Unix as well. Now, if you're going to automate, you can write a shell script, which is a load of shell commands, basically, which are run one after another, or with loops or so on. Unix shells are a lot more powerful than DOS or Windows shells, or certainly historically they were. Microsoft PowerShell is now quite powerful, quite confusing, but quite powerful. But on Windows, you're probably used to calling them batch files. That's the old DOS term for a load of files, a load of commands in a text file that you would just run. You type the name of the batch file and it just runs all those commands for you. And finally on the list, I've got directory, which in Windows is known as a folder. Although in MS-DOS it was known as a directory, but when they changed it to a nice little picture of a folder, people these days tend to refer to them as folders. On Macs they look like folders, on Windows they look like folders, but folder, directory, basically the same thing. In fact, exactly the same thing. So here we go. We're going to get deep into it. You've got to understand how the filing systems worked. Sorry, but this is going to be kind of necessary. So here we have our disk. These are all blocks of data on our disk. This is in the data area, and on CPM you had a file that maybe looked like this: CCP and COM. That's 8 characters and 3 characters. The good old file extension. And this is how CPM organized the files. Files of the same type have the same file extension. There's no such thing as directories. So if you wanted to look at all the documents on the disk, you'd have a look at dir of star.doc, and you'd see all the documents and so on. So you had your directory here. This is the directory, and each directory, as well as the file name, it would have a pointer to where on the disk the file was actually stored. So that file, we'll say, is there. That file might be stored there and there, and they're very, very simple. There's a CPM disk format and a CPM disk directory. Here you can see with the file extensions, they actually mean something. TXT is a text file, doc is a document file, com is a command file. So with CP/M, if you typed a command on the shell, it would look for a com file that had the same name as the command and run it. So if you wanted to run WordStar, you could just type WordStar and it would look on the disk and say, aha, yeah, okay, there's a com file here called WordStar, I'm going to run it, and that would run your word processor for you. So very simple disk structure for CP/M. DOS, at least from MS-DOS version 2, had basically, the files were again stored on the disk like this, but we've got a bit down here which is the file flags, and they could be various things like read-only and archive and so on, and that has carried across to Windows. But the only one that's set here is D for directory, and that says stuff is actually the name of a directory. So that points to a directory here, and these files can be stored. That directory then has pointers to where on the disk the file data is actually stored. And again, WordStar has become an exe file. MS-DOS had COM files and exe files. Exe files could basically be bigger, it was a different format. But there you go, and there's a good old WordPerfect has appeared. So you've got a choice of word processors. Now, by having directories, it was very important, because when you started having hard disks, you had a hell of a lot of files on one disk, and you had to organize them in hierarchical directories. So that is how DOS and Windows could store its files. As you can see, that's still 8 characters and 3 characters for the file extension. Although you had directories, the file extension stuff carried on, because that's how some other stuff in DOS works, like how does it recognize what a command is and what's a batch file. Here's one of them there. Okay, now from Windows 95 or Windows Chicago onwards, things got more interesting. In fact, also with NT, but we'll come to that later. Suddenly, you could actually have upper and lowercase in file names, although because MS-DOS required uppercase only, because hey, not everybody had lowercase on their terminal, it is case insensitive. So readme is with a capital R is exactly the same as readme with an uncapital R. But Windows 95 had a new disk format that allowed you to have long file names. Other than that, it was pretty much the same story. You had, oops, not to there, get it, go away. You had pointers to directories. That would be a file on the disk. That would be a subdirectory, and that would have pointers to where the data was on the disk. Very, very simple, very straightforward. The only difference is you have slightly more information in the directory, and you have long file names. That was in newer versions of FAT. NTFS came along and baked that one in more. Now, Unix files, on the other hand, right from day one, used the Unix file system. And you can see we've got an extra table here. What the blazes is all that about? Now, if you look at a Unix file directory, like this one here, call this one the root, the top directory of the disk, it has, there's our Unix shell, there's the Unix kernel, there's a program called init, perhaps, I don't know. These are just names. They don't actually correspond to a file. They don't point to anywhere on the disk. What they do is point to this structure here, which is another table. This is called the inode table. If I can write it, I don't know. This is the inode table, And this is actually the thing that points to where the files are on the disk. So file 0 points to that, file 1 points to that, file 2 points to that, to that, to that. File 3, that's stored down there, file 4 stored up here. And the files are actually given numbers, 0 to 5 in this case. So the directory hasn't actually got that much to do with it, except what the directory does is it gives you a lookup between the file name and the inode number. So that knows that directory entry is pointing to node 0. This one, shall we say, is the user's home directory, which is pointing to this directory, which is also pointing to inodes. So there's no directory entries. That's probably pointing to that inode there. That inode is pointing to that directory there. So it is not actually pointing from the directory directly to a disk file. This is major. This makes all sorts of weird things possible that really confuse Windows admins. For example, you can rename a file while it's open. It doesn't matter. The inode is the bit that points to the disk. Windows has the MFT, master file table, but it doesn't have inode tables. So the master file table is pointing directly to where the disk stuff is stored on the disk. There is no indirection involved. So if you rename a file in Windows and you're writing to it, you're in trouble. If you rename a directory in Windows and you're using it, you can be in trouble. If you copy a file or move a file from one directory to another while it's open, you're in trouble. It won't let you do it. In Unix, this is perfectly fine because the inode is pointing to where it is on the disk. It's not a bother at all. The other thing that is interesting is, let's say we've got my letter here, which is pointing to inode 3. We can have another letter here. Writing with a mouse is not good. You can have another one here which is pointing to exactly the same inode. So that can be inode 3 and that can be inode 3. What's going on here? Hey, why can't you have a file in 2 different places at once or 3 different places at once? In Unix you can, and actually it's very useful sometimes because you can make a file appear somewhere else for a different user for a different purpose, or you can give a file 2 different names. Sometimes this is very handy. So that's going to be, you've got to understand this whole inode business if you're going to really understand what's going on Unix file systems. It's not quite as straightforward as it looks. The other thing is that this happens to be a program. How do you know that it's a program? Its inode says it's got an X in it. That means that this is actually a program. The permissions for the file are all stored in the inode. Everything is actually stored in the inode apart from the file name. Okay, if you're not getting that, you'll have to really take a good look at how inodes work, because the inode is the thing that tells you everything you want to know about the file. When the file is opened, you open the inode, and all the directory is doing is telling you what the inode number is for the file that you want. There isn't this tight coupling between the two. Okay, said this was going to get complicated. Right, so in Unix, if you compare Unix and Windows, everything is a file. I'll just repeat that. Everything is a file. All your devices are files. All your files are treatable as devices. Let me just pull up a here's a Unix system, happens to be running. If I just, whoa, where's it gone? There we go. Okay, so if I go onto this Unix system here, all the devices are in a device directory called /dev. So if I just get a list of the devices here, I can see them. These are all my devices. So there's ADA0, which is a disk drive. ADA1 is another disk drive. ADA3 is another disk drive. We'll just scroll back down here. TTY are teletypes. Some of these are more complicated. SA is a serial access device. That's a tape drive. That's the control point for the tape drive. That's at the actual tape drive. If you look at ADA2, that's ATA direct access device, which is a disk in other words, and that has a partition 1, partition 2, partition 3. And you can read and write to these as exactly the same way as if you were reading and writing to a file. So if I just switch back to here, this means that things like read, write, seek, all the operating system commands, you can apply them to directories, you can apply them to files, you can read and write from a teletype, you can read and write from a disk drive, you can read and write from a tape drive, you can read and write from a sound card, all neat, orthogonal and straightforward. Device drivers on Windows, on the other hand, are somewhat different. You have specific device drivers. So for example, if you install a tape unit, you're probably going to have some special software that reads and writes to that tape on an application level. It's not so much built into the operating system. On Unix, you can say, hey, I want to copy DA0, which is a disk drive, onto SA1, which is a tape drive, and you just copy DA0 to SA1 and it just copies all the stuff across. Backups become very, very easy. On Windows, you've got to install some backup software and CD-ROM authoring software and goodness knows what. So that's quite a difference. That takes a bit of getting used to. Everything's a file on Unix. And it does actually, it is much more logical. It makes life a lot easier for a lot of things. If you're going to read and write to a file on Windows, you've got separate functions for reading and writing to files as opposed to reading and writing to printers or reading to writing to anything else. So Windows just ends up having more functions and specific device drives with specific functions, and it's kind of evolved over time because it started off without them. CPM, incidentally, had a device for a paper tape reader, a paper tape punch, a keyboard, and a terminal, and that was about it, plus the disk drives A and B. And here we go. Disk drives have letters A, B, and C. They're specific drives. They're just not named devices that are stored into a device directory somewhere. Windows NT has done something to address that, but from the user's point of view, you've got disk drives A, B, C, A and B being floppies, C, D, E, F, G being hard drives usually. And if you want to refer to stuff that's on drive D, you have to put D : in front of the path name. Whereas in Unix, you put your device somewhere on the file tree and it just looks like another directory. Everything's a file or a directory. Looks like a directory. So, everything's a file. That's the takeaway from this page. Couple of things on the philosophy, really. Unix is command driven. You type in commands to Unix to make it do stuff. You want to copy a file, you use the copy command. On Windows, it's got a GUI or menu driven, which means that you select something from the menu to copy a file, or you in fact generally use the mouse to select something, and then you select copy and paste it to somewhere else, or drag and drop it to somewhere else, or so on. Hey, that's really easy. It's very intuitive, not quite so powerful. For example, with Unix, you could just sit down and write a command to say, I don't know, copy all the files in this directory and that directory and that directory that are more than 30 days old and don't end on .tmp and belong to this user, and I want you to compress them and store them in an archive on this machine the other side of the world. Press return and it'll do it. With a menu-driven system, you are limited to what the programmer of the menu-driven system thought you might want to do. So you can't actually express anything, you can just pick stuff from menus. That's what makes Unix powerful even today, once you have got the hang of it. People say Unix is quite unfriendly, which is probably true. Other people say it's vaguely friendly, it's just a bit picky about who it makes friends with. So, difference in philosophy. Unix has remained command-driven, and Windows moved towards menu-driven and GUI-driven. Now, you can get GUIs that run on top of Windows. In fact, they've been around for a very long time. And you can have a Unix workstation, and you can use it as a desktop machine with a graphic user interface. My guess is that's not what you're going to be doing with it. If you want to run a Linux desktop, Linux is quite good for desktops. Go ahead. If you feel comfortable with it, you're not going to be running the powerful stuff that you would be doing as a server, though. Windows does actually have commands for advanced operations. Windows PowerShell, if you want to sit down and use it, is pretty powerful. It can do all sorts of stuff. You can script it. And there are a lot of things, for example, PowerConfig, that you can only do from the command line. So if you get deeply into Windows, you'll be using the command line as well. Unix culture has a culture of scripting, where you would write scripts to do something. So rather than doing repeated mouse movements to copy this file, that file, and the other file, you'd actually just write a script, a shell script, that would do all the files that you want to do on a regular basis and do it that way. Whereas Windows, again, has the point and click culture. You point at something, you click on it, you do something with it, and as long as the graphical shell of Windows can actually do what you want, that's well and good. It might take quite a lot longer, it's much more difficult to automate, but it's much easier to use. So, moving along, other differences. Okay, and this is partly cultural and partly implementation. Unix uses config files for individual applications and services. If you've got an Apache web server, you want to make it do something, you edit the text file that configures Apache. If you want it to do something on startup, you write stuff in the startup scripts for it. If you want to configure your mail server, you load up the config file for the mail server and edit that. It has a lot of advantages, but I'm not really going to get into that too much right at this stage. Windows is very, very different. Since Windows Chicago, that's Windows retail version 95, they went really all in for a centralized database called the registry. So all configuration for all applications is now stored in this humongous Windows registry, which of course you get at using the registry editor and various other things. It's got a big centralized database, and this is a very Windows thing. IBM's AIX Unix uses a database called the ODM, which is actually very similar to the Windows registry. It hasn't quite gone all in because there are still individual configuration files, but that's the outlier. AIX is about the only one that uses a central registry or database called the Object Data Manager, I think it's called. Solaris has a system called SMF, but it's not fully centralized. And Mac OS again uses plists, which are kind of there, but again, it's not really centralized. It's just more a formal way of writing configuration files. Which is exactly what Windows did before Chicago. If you remember .ini files, everything had its own .ini file, and Windows itself had system.ini and win.ini and so on. Those were the good old days. If I just switch over to a command line here, I'm just going to show you one. So here's, if I just load up an editor, this is the startup script for this version of Windows, and it has sort of Windows, what am I talking about, of Unix, and it has various options and things that I have set for it to do. There. Okay, here's a load of other configuration files for other things. Okay, so this tells it where it's getting its name servers from. They tend to be called .conf unless they're called something else. But these are all there. Here's a good one. If you look at hosts, this hosts file, because Windows was copied a lot of stuff from Unix. If you look in Windows System32, etc., drivers, etc., you'll find a hosts file which is exactly this format, because Windows copied Windows networking. This is just got a load of comments on, and it's got a few hosts defined in it. But anyway, it's using config files in quite a big way. Okay, if I just come out of that. So if I come back to here, we can move on to the next topic, and this is special characters. Again, things you should know about but may not have been told. So in Windows, any character you like can be part of a file name. Absolutely any. There's just two exceptions. One is the / character, which is necessary for separating directories, and the other is the null character, all bit 0, which in Unix, which is written in C, is the way of terminating a string. So you only know you've got to the end of a file name when you get the null character. But anything can go into a file name, including control characters, anything you like. Windows, on the other hand, well, it started off with A to Z, 0 to 9, and an underscore. Ah, boring. And if you had a dot, it was separating the 8 characters to the file extension. So all you had was 8 characters, A to Z, 0 to 9, and they had to be uppercase as well, or it ignored the case. Later, Windows Chicago onwards, you could have lowercase, space, and most others in your file names, and the file names could be as long as you, well, a lot longer than they were before. In fact, the limits do change a little bit. I think there's 9 characters that you're not allowed. Things like a colon, for example, which it uses for specifying a disk drive, A, B, C, A, colon, B, colon, C, colon. You can't have a / character in it. You can't have a star in it. There's a few that you can't have. But legacy systems, it gets a bit risky. By the way, just because you can have any character in a file name really does not mean it's a good idea. If you put non-printable characters in, no one will even know the character's there. It drives you crazy. But anyway, so Windows has a more restricted set of characters than Unix, which is something you want to bear in mind if you're copying a load of files from Unix to Windows. You might hit characters that Windows just can't cope with. Command options, right? So, you know, in Windows, if you type dir/s to do subdirectories, you use a slash character for the option which modifies what the command does. In Unix, pretty much everything for the last 40 years or so has used a dash instead of a slash to specify an option. Say I've got down here all system defined because Windows or Microsoft, this was MS-DOS timers actually, and for OS2, they realized, oh dear, a slash is going to conflict with Unix, and we're kind of moving towards Unix. So there was an option on OS2 to select what you wanted for your option character, but it required all of the utilities to actually look to see what option character we were using today. So that's pretty much died a death. It's pretty much usually a slash followed by a flag. In Unix, again from day one, the backslash has meant quote the next character. So if you have backslash return, it just takes the return literally. This is how you can get odd characters into file names. If you put a backslash and anything you like, it will literally be passed straight through as part of the file name. Backslash space means pass this space and what follows it as part of the file name, which is how you can which is how the system can tell the difference between a file name like hello space world. Is it one file name called hello and one name called world or not? So if you put a backslash in front of it, it means this has no special significance, just pass it through as part of the character. Not a lot of people know this actually, but Windows has a similar mechanism which they can't use the backslash character because they've already used that for directories. So it's the little up arrow has the same effect. And then, of course, there is the directory separator. In Unix, it's a slash character. It can't be the slash character in Windows because in DOS they went and used the slash character for options. Bad choice. So they had to use the backslash character. Except, guess what? It's only the backslash character on some versions of Windows. In other versions, it's that character. That would be Japan, Korea, it's that. It can actually vary depending on which version of Windows you're using. It's a bit of a mess. But anyway, Unix has kept everything since the 1970s nice and straightforward and simple. Windows is a little bit more complicated, and you just have to be aware that there are in fact differences. And that's about it. I hope you've found this quick run through useful. These, as I say, this is not a tutorial on Unix or Linux. These are just some of the things that confuse people and you want to be aware of that are not often explained when people just start using Linux. They don't want to go into the differences, particularly, as I say, I spent quite a lot of time going on the filing system. The file system is actually different. It is much more complicated. It is much more powerful. And you're going to start looking at the file system thinking, what the hell's going on here? But I hope if you understand what the indirection from inodes, that will get you going better. Thanks for watching. I hope you enjoyed it, and watch out, I'll be putting some more mostly BSD stuff on this channel in the future.